Welcome. We're talking about logarithms today. And in a logarithm, it's typically written the log base b of y equals x. Log base b of y equals x. And what does that mean? That means b is the base of the exponent. The exponent is what it's equal to. And what you're taking the log of is the answer when you raise the base to the exponent. So it's kind of like trying to figure out what the exponent is of what you want. What would you have to raise b to get y? That's what the logarithm is. Then there's something called a common log. Getting very drudgy today. All right, a common log is just log. If you just see log, you know it's a common log, which is log base 10. That's what we're working with when we see common log. If it doesn't have a base, it's assumed to be base 10. Kind of like when you have a square root, the index is assumed to be a 2. Or when you write x, it's assumed to be 1x to the first. It's assumed to be base 10. All right, so now let's rewrite into exponential form from logarithmic form. Log base 2 of 16 equals 4. So 2 to the 4th power equals 16. That's what that means. Try that one. 7 to the 0 equals 1. 7 to the 0 equals 1. There it is. Base 7, exponent, what it equals. All right, let's take a look at this one. In this one, if I want to write that as a log, what is being raised to the power? 1/2. What is the result of the power? 4. So that's what you're taking the log of. And it equals the power, -2. So 1/2 to the -2 power equals 4. So the log base 1/2 of 4 equals -2. That's how you do it. I'm sure you'll have lots of questions. Let's take a look at this one. Now we're talking about evaluating a log. Or no, rewriting a log still. Rewriting a log. Go ahead and try that one. Rewrite that log into exponential form. That's a common log, so it's base 10. The exponent is on the other side of the equal sign from the log, and what you're taking the log of is what the variable, or the base to the power, equals. Write the logarithmic form. Log base 4 of 64 equals the power 3. I have never been good at thinking in terms of logs. I've always needed to think in terms of exponents. So let's take a look at a couple of basic information pieces. Any base other than 0 to the first, any base to the 0 power equals 1 other than 0. So if you're taking the log of 1, the answer is 0. Because b to the 0 equals 1. B to what power equals b? B to the first. Because only b to the first equals b. All right, that's interesting. Let's look at this one. We're evaluating now. I said a few minutes ago, I have a hard time thinking in terms of logs. So I rewrite this and say 2 to what power equals 64? Well, if you have to count with your fingers on this, be careful. When you say 2 times 2, don't go 2 times 2. That's 2 times 2. 2 times 2 is 4, times 2 is 8, 16, 32, 64. So that would be 6 is your answer. Log base 4 of 1/16. 4 to what power equals 1 over 16? Well, we know 4 squared equals 16, but to make it 1 over, negative. So 4 to the negative 2 equals 16. And how about this one? 16 to what power equals 4? Well, wait a minute. Isn't that kind of backwards? Well, think radicals. Think square root. What power is square root? The 1/2 power. So 6 square root of 16 is 4, so to the 1/2 power. 16 to the 1/2 power is 4. All right, let's take a look at our next example. This is a little tricky, and it takes a little explanation. Let's go through this. B, if I rewrite this as an exponent, b to the x equals b to the x. That's what that's saying. When the base and the base are the same, the exponent is the answer. When the base of the log and the base of what you're taking the log of, which is something to a power, if these two are the same, then the exponent is the answer. So over here, 8 to what power would equal 8 to the 7th? Well, 7, because the powers would have to be the same. That's a question mark, by the way. All right, let's take a look at this one. The base of the exponent and the base of the log in the exponent are the same, so what you're taking the log of in the exponent is the answer. Here's the reason. If I write this as a log, log base b of x equals the exponent log base b of x. So the answer is what you're taking the log of in the exponent when the base of the exponent and the base of the log in the exponent are the same. So do we have anything more after that? Yes, we do. Let's take a look at this one. So we said when the base and the base are the same, then what you're taking the log of has to be the answer. Let's just confirm that. this is the base 2, oh sorry, we're going to write that as a log. The log base 2 of question mark has to equal the exponent, log base 2 of 3x. So question mark has to be 3x. And that is just about it. I do want to do one more. Let me just get rid of this, extend it, and let's take a look at this one. Log base 5 of 125 to the 2x. Well, wait a minute. The base, that's a base for the log. I didn't draw that very well. Let me rewrite that. Log base 5 of 125 to the 2x. The base and the base of the power are not the same. Can't we rewrite this as 5 to a power? (125) is 5 to the third. And can't I rewrite that as, when I have a power to a power, I multiply the exponents? 5 to the 6x. So when the base and the base are the same now, the power is the answer. 6x. All right. Your homework is in Google Classroom. Good luck. Have a great day.